So if you took 1/10 of the volume of the Mississippi River and diverted it into the Colorado River, would you be able to fill up Lake Mead and Lake Powell in about a year? Yes. But how exactly are you going to transport that amount of water? I've given my opinion before on these schemes of taking water from the Great Lakes or the Mississippi and moving it to the west. But let's just pretend for a moment that we were actually going to try it. The Mississippi River is roughly putting out 13.5 acre-feet every second, which is almost 600,000 CFS. 10% of that works out to just under 60,000 cubic feet per second. Now these are just numbers on a spreadsheet. What can we compare that to? What does that actually look like? Well, if we compare it to other rivers in the U.S., 10% of the Mississippi ends up being somewhere between Red River in Oklahoma or the Snake River in Washington. I mean, these are not small rivers at all. Now let's compare this amount of water to some existing canals. The largest irrigation canal by volume right now is the All-American Canal, which can move 26,000 cubic feet per second. That's less than half of what we need. Not only that, but the All-American Canal is entirely gravity-powered. And our Mississippi to Lake Powell route will have to go uphill. Both the Colorado River Aqueduct and the Central Arizona Project make use of pumps, but they're tiny compared to what we're talking about. The closest comparison I could find was the California Aqueduct, which moves water from the California Delta into the Central Valley, and uses some really big pumping stations to get it up there. But even that is nothing close to 50,000 cubic feet per second. Remember, every major water project uses gravity for the majority of its route. Pumping up and over mountains is always the exception, not the rule. But a Mississippi to Lake Powell pipeline would be uphill the entire way.